Hello, class. Let's dive into this algebra problem. It looks a little abstract, but it's a great example of how the SAT tests your knowledge of core algebraic identities. We're given one equation, 3x squared equals 2a, and asked to find the value of a completely different expression. The key here is that the answer must be in terms of a, which means we need to find a way to eliminate x. Our strategy will be a two-step process. First, we'll focus on the expression they're asking about. Open parenthesis, 3x minus a, close parenthesis, times, open parenthesis, 3x plus a, close parenthesis. We'll simplify this as much as we can. Then, in our second step, we'll use the given equation, 3x squared equals 2a, to substitute and get our final answer. Let's begin with step 1. Okay, take a close look at the expression we need to simplify. This form, something minus something else, times something plus something else, is a special pattern you must know for the SAT. It's called the difference of squares. The formula, as you can see on the screen, is p minus q times p plus q equals p squared minus q squared. Recognizing this pattern saves you from having to use the FOIL method and is much faster. Now, let's apply this formula to our specific problem. By comparing 3xa, 3x plus a, to pq, p plus q, we can see that our p term is 3x and our q term is a. So when we apply the formula p squared minus q squared, we get 3x squared minus a squared. It's a direct and simple application of the rule. Our expression is almost simplified. We just need to handle the 3x squared term. A common mistake here is to only square the x. Remember to square everything inside the parentheses. So 3 squared is 9, and x squared is x squared. This gives us 9x squared. So after applying the difference of squares formula and simplifying, our original expression has now become 9x squared minus a squared. This is much cleaner and easier to work with. This concludes step 1. All right, let's move on to step 2. Here's where we bring in the other piece of information from the question. The problem states that 3x squared is equal to 2a. Our goal now is to use this fact to eliminate the x squared from our simplified expression, 9x squared minus a squared. Now you might be wondering how we can use 3x squared when our expression has 9x squared. This is a very common trick on the SAT. We can cleverly rewrite 9x squared. Since 9 is just 3 times 3, we can express 9x squared as 3 times 3x squared. By rewriting it this way, we've created a piece that exactly matches the given equation, making our substitution possible. This is the key moment. Since we know that 3x squared equals 2a, we can directly replace the 3x squared in our expression with 2a. So 3 times 3x squared minus a squared becomes 3 times 2a minus a squared. The x variable is now completely gone, which is exactly what we wanted. We're on the home stretch. All that's left is to simplify. We multiply 3 by 2a, which gives us 6a. So the final expression is 6a minus a squared. We have successfully found the value of the original expression purely in terms of a. So, to conclude, our final answer is 6a minus a squared. Looking back at the multiple choice options we were given at the start, this result matches option D. And that's our final answer. By correctly identifying the difference of squares and performing a careful substitution, we solved the problem efficiently. Great job, everyone! Remember to keep an eye out for these algebraic patterns. They are your best friends on the SAT. See you next time.